All right, let's get into it. Today, we're going to tackle something super important, giving your Jenkins server the power to talk to and command a Kubernetes cluster. We're going to build that essential communication bridge, and we'll do it step by step.
You know, the best way to think about this is with a simple analogy, and it really sets the stage for everything we're about to do. Just picture Jenkins as this super efficient factory manager. It's ready to automate the heck out of everything. The problem is, to give orders to its delivery fleet, that's our Kubernetes cluster. It needs the right tools to communicate.
Okay, so here's the game plan for today. First, we'll talk about why the factory is silent in the first place. Then, we'll actually forge the radio, find that secret frequency to broadcast on, make our first contact, and, just in case, we'll cover how to troubleshoot any static on the line.
Right, so picture this. You've got this awesome Jenkins server, our factory manager. And over here, you've got this powerful Kubernetes cluster, our delivery fleet. The catch? They're in totally separate worlds. The manager has no way to give orders. Our job today is to build that bridge between them so Jenkins can finally start deploying, managing, and orchestrating everything inside Kubernetes directly.
First things first, we've got to give our factory manager its radio. And that radio is the Kubectl command line tool. Seriously, this thing is like the universal remote for any Kubernetes cluster out there. We're going to install it right on the Jenkins server, and I'll walk you through every single command.
Okay, don't let this command scare you. I know it looks like a lot, but it's actually really smart. What it's doing is dynamically grabbing the latest stable version of Kubectl right from the source. This means you're always up to date and you don't have to go digging around for version numbers yourself.
So what's the magic behind it? Well, it's really two commands smashed into one. See that part in the parentheses? That inner command runs first. It basically calls up the Kubernetes servers and asks, hey, what's your latest stable version number? It gets an answer, let's say it's v1.30.0, and then it immediately plugs that number into the main download URL for the outer command. It's just perfect self-updating automation.
Now you might be thinking, hold on, why not just run a simple apt-get install? And that's a totally fair question. Here's the deal. Using curl this way guarantees you get the absolute latest stable release, straight from the horse's mouth, the official source. Sometimes those package managers can be a little behind, serving up a slightly older version.
Great, so the file is downloaded, but we can't run it yet. See, by default, your system is pretty cautious for security reasons. It won't let you run downloaded files as programs. This little command here, chmod +x, is what flips that switch and tells the OS, yep, this one's a program, let it run.
Let's zoom in on that for a second. Chmod just stands for change mode. It's a classic Linux command for messing with file permissions. And the +x part, that's what adds the executable permission. So we're literally telling the operating system, hey, this kubecontrol file, it's not just a bunch of data, it's a tool. I need to be able to run it.
Okay, last step for the install. We're going to move our new Kubectl tool into a very special directory, /usr/local/bin. Now this isn't just about keeping things tidy. This is the key to making the command available system-wide, so Jenkins can call on it from absolutely anywhere.
So how does that work? It's all thanks to something called the system path. Just think of the path as a list of addresses. When you type a command, the system checks all those addresses to find the program. Since /usr local bin is on that list, by putting kubecontrol there, we can just type kubecontrol from any folder and the system knows exactly where to go find it. Super convenient.
All right, this is the moment of truth. Let's run kubectl version. What you're looking for is the client version. If you see that, boom, our radio is installed and working on the Jenkins server. Now you're almost definitely going to see an error for the server version. Don't panic. That is totally expected. We've built the radio, but we haven't tuned it to the right frequency yet. That's next.
So we've got our radio, kubecontrol, ready to go. Now it's time to tune it in. We need to find that specific frequency that lets us talk to our Kubernetes cluster. And that frequency? It's all stored in a really important configuration file called the kubeconfig.
Getting this right is kind of like a careful three-step dance. Step 1. On our Jenkins server, we create a specific directory where kubecontrol expects to find its settings. Step 2. We hop over to our Kubernetes master node and just display the contents of its existing config file. And step 3, we securely copy that big block of text and paste it into a brand new file on our Jenkins server.
You're probably wondering, what is all this stuff we're copying? It looks complicated, but it's not magic. It's a very structured file, and it has everything Kubectl needs to make the call. It's got the cluster's address, the security certificates to prove the cluster is who it says it is, the user credentials so Jenkins can log in, and something called a context that ties it all together.
Now, I need to be absolutely crystal clear about this. This file, you have to treat it like the master key to your entire kingdom. It contains credentials that grant complete administrative access. Now, in a real-world production setup, you would almost never do this. You'd use something called role-based access control, or RBAC, to create a special, limited user just for Jenkins. But for our setup here, we're using the admin keys just to get everything connected and prove it works.
And because this file is so ridiculously sensitive, you have to handle it with extreme care. I mean it. Never, ever email it. Don't paste it into Slack. Don't you dare commit it to a public Git repository. You need to use secure methods like SCP or just copying and pasting directly inside your secure SSH terminal. You have to protect this file.
Okay, the radio is installed. The frequency is tuned. This is the moment we've been working towards. Let's see if our factory manager Jenkins can finally make contact with the delivery fleet, Kubernetes.
Our first test is just a simple radio check. We'll run kubectl cluster info. If we did everything right, this command should reach out across the network, find our cluster, and get back a response with the main addresses. If you see that, it means the connection is live. We have a signal.
But here comes the real proof, the ultimate confirmation. We're going to run kubectl get nodes. When this command comes back with a list of all your worker nodes, and you see that beautiful ready status next to them, that's it. You've done it. That is definitive proof that your factory manager has full visibility and command over its entire fleet. Of course, sometimes that first call is just static. If your commands don't work right away, don't sweat it. It happens. It's usually one of a handful of common problems, so let's quickly go over the usual suspects.
Okay, here are the top 3 culprits. If you see connection refused, that's almost always a firewall issue. Something is blocking the network traffic between Jenkins and your cluster. If you get certificate errors, it means something is wrong with the security credentials. And you'd be surprised how often it's just a simple typo in the server's IP address inside that all-important kubeconfig file. Double-check that first.
So there you have it. You've built the bridge, you've connected the factory manager to the fleet. The communication channel is open. Now the real fun begins. And the question is, what are you going to automate first? Deploying an app with a single click? Kicking off a complex rolling update? The possibilities are now wide open.